Hello, my name is Neil Lumas and this is
Adrian.
and today we're going to talk about normal distribution.
So now let's talk about binomial distribution. This very topic. So the characteristics of binomial distribution is that it is symmetric along the mean and it is asymptotic in the x-axis. So binomial distribution, first of all, is represented what is called binomial curve. In short, this is its graph. So first case is that it's symmetric along the mean, which means the mean is always the center. It's asymptotic to the x-axis, which is this one, which is right here. It looks close, going closer to the x-axis, but it's not touching the x-axis until infinity. And its mean median rule or equal, and its empirical rule. Now, what is the empirical rule? The empirical rule is something like this. One standard deviation, meaning one standard deviation, here is plus n, plus the mean is equal to 0.68, 0.6826%. And we add another standard deviation to the mean, we go to 0.95. Or just in case 95.44% until infinity.
So now that you know the properties of normal distribution, we will be discussing about the origins of these properties and how the normal distribution concept came to be. The normal distribution is also known as the Gaussian distribution. It is named after the mathematician Carl Friedrich Gauss, who derived the equation of the probability density function. The normal distribution follows the central limit theorem. As shown in the following pictures of coin tosses, we can see that it gradually creates a bell-shaped curve. Depending on what is needed, there are many variations of the shaded area in a normal distribution. One of the examples are the probability that z is greater than or equal to k. Before we proceed to actual problems, we must first learn to how to use the z table. In this column, you can see that there are values going from here downward and here. So what you need are the z-scores. In order to z-score, to get the z-score, we use the formula x minus the mean over the standard deviation. And whatever is the result of this is what you're gonna use to find the value. So let's say I got 1.3 as my z-score. So we look at 1 and then we see the corresponding 0.3 value there. That means 0.3485 will be the area under the shaded part in the normal curve. In this problem, we are looking at the probability of x being greater than 135. So the shaded part will be here, going to here, since we're looking at the probability that is greater than 135. So by performing the calculations, we know the value is 1. So therefore, we just have to look 1 on the z table, and that will be the area under this part. In this example, we are looking at the probability that x is less than 105. Since this is the value of 105, we are shading the left part. And this will be the area with a value of -1. In this problem, we are looking for a value that passes in between the mean. So let's say this is the value of 135 and this is the value of 120. Since it passes through the mean, we have to calculate for both differently. So in the end, we will get a -1 and +1, and then if we add it together, we'll get the total area. Now we are gonna move on to exercises involving normal distribution. For the first exercise, the problem is the running speeds of students are normally distributed with a mean of 7 meters per second, the standard deviation of 2 meters per second. What is the probability that a student runs more than 5 meters per second? So in order to solve the problem, we must first get the z-score. So following the computation, that's 5 minus 7 over 2, which results in -1. But keep in mind that with this kind of problem, we are actually looking at the values to the right of 5. Since it passes the mean, we must add 50% to the area here in order to get the entirety. So the probability that x is greater than 5 is equals to 84.13%. We got this value by adding the z-score value of -1 and 0.5, which is equals to 50%. In this problem, since we are asked to draw the normal curve of v, we just have to get the mean and then add the standard deviation to the right and subtract the standard deviation to the left. Earlier, my colleague discussed about the empirical rule. So one possible application of empirical rule is in this problem. You see that the value of 70 and 130 both lie in two standard deviations away from the mean. So this is the value of 130 and this is the value of 70. This means that the answer is automatically 95% since we can use the empirical rule.